In this video, we are going to be focusing on the structure of alanine. When we say alanine, this is simply one of the 20 stranded amino acids that occur naturally in protein and it's commonly found in human body. And the structure of alanine is non-polar aliphatic amino acid. Its chemical structure consists of central carbon bonded to one hydrogen, an amino group, a carboxyl group, and a methyl group. So in this case, the molecular formula or the chemical formula for alanine is simply 3 carbon, 7 hydrogen, 1 nitrogen, and 2 oxygen. Let's draw the structure of alanine. First of all, let's start with the numbers of carbon to make sure that everything is accurate. Here we have 1 carbon, 2 carbon, and this is the 3rd carbon. So in this case, we're going to separate the methyl group separately. We're going to separate the carboxyl group, and we're going to separate the amino group. And they're all going to connect on those numbers of carbon here. So how can we draw starting with the right hand side, the carboxyl group? Carboxyl group is double bond. It's going to be 2 oxygen connected with just 1 hydrogen. What about the amino group? The amino group is simply 1 nitrogen with 2 oxygen. Here we have 1 nitrogen with 2 oxygen. Connected with what? 1 hydrogen. Here we said, but don't forget we said it has 1 central carbon connected with hydrogen. If this is the central carbon, we are going to have 1 additional of hydrogen here. In the case of the methyl group, it's simply what 1 carbon saturated with 3 hydrogen. 1 carbon connected with 3 hydrogen. So this time around, everything is going to connect. And this is it for this problem. If you take a look at it from the molecular formula, we have 3 carbon, and this is carbon number 1, number 2, and number 3. We have 7 hydrogen. In the case of hydrogen, we have 1, 2, 3, 4, 5, 6, and this is the 7th one. We have 2 oxygen. For the oxygen here, we're going to have 1, 2. What do we have next? We have 1 nitrogen. This is what? This is simply going to be 1. But we can choose to write it differently by drawing just this structure. But in this case, we are simply going to separate. Let's take an example with this. If you're given something like this, just know that here we have what? 1 carbon, 1 carbon, 1 carbon, right? Making it how many carbon? 3 carbon. Let's try to draw the structure other way around, or using the 3D format. So in this case, we're going to have, let's start with from the left hand side with the carboxyl group. We're going to have carboxyl group on this bond, followed by the amino group. But in alanine, most of the time, the amino group is facing toward the viewer. If it's facing toward the viewer, in this case, we're going to be using the wedge line. So this is going to be the alanine group. It's going to be, in this case, since it's facing toward the viewer most of the time, that's in 3D dimensions. We're going to have 1 nitrogen with 2 hydrogen. So for the methyl group, which is this, which is CH3, we're simply going to connect it down here, which is CH3. The next thing we have on the list is the carboxyl group. Don't forget, carboxyl group is always double bonded, connected with 1 hydrogen and 2 oxygen. But still, if you like, you can choose to write it differently by starting with the methane, which is 1 hydrogen connected with 1 carbon. But remember, always our amino group is in what? Is facing toward the viewer. If it is facing toward the viewer, in this case, we are going to have it in what? Wedge structure. I have explained that on my previous video. Feel free to check it. So we have what? Our amino group here, NH2. The last thing we have is carboxyl group Carboxyl group, we said, is double bonded, connected with 2 oxygen and 1 hydrogen. So this is it for this problem. Thank you for watching, and I hope you find this video helpful. If you did, please don't forget to share, like, and subscribe. Thank you.